Now let's look at example number 1. The diagram shows load carried by a beam. Calculate the maximum shear force and maximum bending moment, which means that this question asks for the value of maximum shear force and maximum bending moment. And in order to get that value, we must draw the shear force diagram and bending moment diagram. Therefore, the first step that kita kena tengok the figure here, which is the beam and the loading, the system itself, and identify ini jenis apa and ini jenis apa. This is pin or hinge support, and the other one is roller support. From what we see here, we know that this 5 kilonewton adalah point load. Load yang concentrated at one point to this particular beam, right? What we need to do first, kita kena cari reaction. Draw the beam again with the loading, okay? And don't forget that it's much easier kalau kita namakan. Okay, this is A, B, C, D. Okay, letak. So I buat benda yang sama to the system down below tu. So we can identify the reaction at the support. Okay, at the support A, as you can see, it's pin or hinge. Okay, you know that there is a reaction dekat arah Y. Therefore, we put there RAY, which is A is the name of the point lah. Okay, RAY. And pin pun mesti ada RAX. Why? Because pin can allow for rotation, which is the moment. But pin don't allow for any movement horizontally or vertically. Arah Y atau arah X direction is not allow for pin untuk move. Okay. And for the support at D, this is roller. So roller allow for moment, which means boleh rotate, and allow for horizontal movement. X axis dia allow. Therefore, one thing yang dia tak allow adalah arah Y direction movement. Therefore, I put here RDY. So itu yang kita nak cari. We can take moment at any point sebenarnya untuk solve this question, tapi lebih senang kita take moment dekat the support. Okay, so I take moment dekat A. I buat the moment equation sebab I nak dapatkan reaction kan. So I take moment dekat A, automatically any reaction at point A will be 0 sebab walaupun RAY tu sebenarnya ada value, but because of the direction, there is no direction sebab dia dekat point A juga, so dia nak pergi mana kan, the distance also going to be 0 sebab dekat point A juga, kita take moment kat situ and the force pun dekat A juga kan, that's why dia jadi 0. So kita take moment dekat point A. Apa saja yang clockwise, the moment going clockwise is equal to the counterclockwise moment, which means in equilibrium. Okay, so kita nak tengok which one is clockwise. So clockwise, we take anything semua dekat A, the force going to be going to A. So 5 kilonewton going to A. Okay, 5 kilonewton here also. So ini obviously clockwise. And counterclockwise, kita nampak ada satu kat sini, which is the RDY. Right, so kita ambil yang clockwise dulu to put in our equation down here. 5 kilonewton. Okay, ini adalah moment equation, which means you have to times the distance. So times 3 meter plus 5 kilonewton times 7 meter equal to, itu je kita ada for clockwise, and for the counterclockwise we have the RDY times with 10 meter distance. Then I get 50 kilonewton meter here when you simplify it, and R dy times 10 meter here. Kita boleh solve this problem by 50 kilonewton meter divide with 10 meter. Then we get 5 kilonewton. Ini adalah R dy. Therefore, that's why dia dalam kilonewton. This is force. Kita nak dapatkan the value for the force, the support at point D. And next, we have another two reaction that we don't know. You boleh cari, doesn't matter nak cari arah X dulu ke arah Y dulu ke. I ambil arah X dulu. So, total force equal to 0. So, here I buat force equation because force equation ni lebih senang. Okay, you boleh buat moment equation juga, tak ada masalah tapi dia akan menyusahkan you sebab you kena dengan distance and what not. That's why kita choose to. Okay, satu kita buat moment equation. Once kita dah dapat one of the unknown, baru kita boleh guna the force equation. Kalau kita ada dua unknown, kita nak pakai the force equation is going to be a bit complicated sebab kita ada dua unknown dah. So kita pakai dulu moment equation first to get the first unknown, then we can use the easier method which is the force equation to get another unknown. Force going to the right will be equal to force going to the left. Right, so if we look at the beam, okay, there is only one force going to the right which is the reaction. Okay, there's no other horizontal or lateral force. Okay, RAX equal to 0. Okay, that is our answer. Tak ada lain. Tak ada lagi force lain kan. Next, kita akan kira for another unknown which is the RAY. We can use the force equation again but arah Y. Force going up equal to force going down. To get this value, kita kena tengoklah our beam here and identify which one is going up. Ini going up, going up. And the one yang going down, we have 5 kilonewton and 5 kilonewton. There's no other forces. Ini ada 4 sahaja. And kita pun dah tahu the value of the RDY which is kita boleh replace kat sini 5 kilonewton untuk memudahkan kita kira. So we have going up RAY plus RDY equal to going down 5 kilonewton plus 5 kilonewton. And we already know RDY is 5 kilonewton. Just replace the value and you will get something like this, which you will get the RAY equal to 5 kilonewton. For the next step, baru kita akan dapat draw the shear force and bending moment. Kita kena buat garisan lukis balik the beam yang you kira tu, okay? And sebenarnya you dah ada the value of RAY, RAX, RDY. RAY adalah 5 kilonewton, RDY is 5 kilonewton and RAX is 0. Nak letak pun tak apa, tak letak pun doesn't matter. There is no actually direction sebab there is no magnitude, so kosong lah, tetap kosong Kita kena buat garisan untuk draw the shear force and bending moment dekat setiap point yang ada force atau loading. A, B, C, D semua ada force atau loading. Okay, A ada reaction, B and C ada loading and D ada reaction. So semua ni adalah force Nama dia pun 5. Unit dia pun kilonewton, so it's a force lah. Atas ni adalah for shear force diagram which I put here SFD. And below here adalah bending moment diagram or BMD. Okay, tu short form dia. And yang belah atas daripada garisan biru for SFD adalah value dia positif and belah bawah value dia negatif. Same goes with BMD. Above 0, above the blue line is positive value and below the blue line is negative value. Okay, you can put the other way around, doesn't matter as long as you label so that when people see, people understand. If you don't label, then orang pun tak tahu ni value apa. Dekat garisan tu adalah point 0. Okay, so kosong. Betul-betul kosong kat situ. Okay, so kita buat SFD dulu. SFD, bila kita cakap about equilibrium, okay, it must always start with 0. At point A, you see there is a 5 kilonewton going up. Okay, reaction dekat situ naik atas 5 kilonewton. For 3 meter, there is no force. Dia akan pergi straight. At point B, there is one loading going down as the value is 5 kilonewton, which means dia turun bawah, kita kena minus. So 5 kilonewton minus 5. Dia akan get back to 0. And for 4 meter from B to C, there is no load at all. Then dia akan go straight. And at point C, you nampak ada 5 kilonewton going down. Meaning 0 minus 5. Sebab dia turun ke bawah, kita kena tolak. Dia become negative. Next, C to D. No force, and then 5 kilonewton going up. So dekat sini kan, dia stop dekat situ, which means that value dia negative 5 lah. Okay, and then kita nampak negative 5 and then ada point D 5 kilonewton naik ke atas, which means negative 5 plus 5. Then you akan dapat balik kosong. Okay, so because of kita cakap ini equilibrium. Equilibrium will start with 0 and end with 0. Siaplah our shear force diagram. Next is we need to calculate or draw the bending moment diagram. To calculate bending moment, nama pun bending moment, which is it is a moment. So bila moment maksudnya force darab dengan distance. So force darab distance, kalau you tengok BMD, ada tak dalam beam ni any rotation, any value of rotation? For example like this car, ada ke? Tak ada kan? No, you don't see any rotation dekat dalam the diagram. However, we know that force will cause moment. Force will cause rotation. Okay, jadi because of force will cause the rotation, so force darab dengan distance adalah moment. Kalau you tengok dalam you punya shear force diagram, you see that the force here adalah 5 kilonewton and the distance adalah 3 meter. Kan? Untuk the first one, A to B. And same goes with C to D. The force adalah negative 5 and the distance adalah 3 meter. So kita boleh dapatkan moment. Okay, nak senang cerita, kita kira macam kita kira area. Area mana? Area yang ada rectangle ni. Kenapa kita abaikan B to C? Dia tak ada area. So kita tak boleh kira. Okay. So sebenarnya dia punya application sama lah macam kita kira area, but it's actually a moment. 1, 2. I name it like this, then it must be easier for us to calculate the area ataupun calculate the moment. So I get the first area, which is area number 1 dah. Okay. So we know that the force is here, 5 kilonewton. Darab dengan, okay, the distance is 3 meter. Ataupun macam kita kira rectangle kan, panjang darab tinggi. Tinggi dia 5 kilonewton, panjang dia 3 meter. So kita darab 3 meter. You will get 15 kilonewton meter. For area number 2. Area number 2, the force ataupun tinggi dia adalah negatif 5 kilonewton. Darab dengan panjang ataupun the distance adalah 3 meter. You will get negatif 15 kilonewton meter. What we need to do next, kita akan draw the diagram for PMD. We'll start with 0. Whatever it is, kena start dengan kosong. Okay, the first area is 15 kilonewton meter. So when it is 15 kilonewton, positive value at the end of the area, which is dekat point B ujung area tu. Point B itulah ujung area tu kan. Okay, kita akan letak value area tu, which is 15 kilonewton, positive value. Dia duduk kat atas lah. So garisan dia macam mana? Dia slanted but straight. Next, point B to C, there is no value for moment. Maksudnya bukan tak ada moment, maksudnya tak ada perubahan moment, which means dia akan go straight. Straight line saja, value dia sama 15 kilonewton meter. And at point C to D, okay, other area which is negative 15 kilonewton meter. Okay, ada moment, maksudnya 15 kilonewton meter yang kita ada setakat ni tolaklah dengan this 15 kilonewton meter. You will get back to 0. Okay, so dia akan start dengan kosong, dia akan berakhir dengan kosong. Kalau you tak dapat start dengan kosong, berakhir dengan kosong, jawapan you salah lah. Sebab dia tak berada dalam equilibrium. So, this question asks you to find the maximum shear force. Okay, and the maximum bending moment. For maximum shear force, daripada our gambar just ni, berapa value paling maksimum? 5 dan negatif 5. So, kita letaklah 5 kilonewton, value paling tinggi. And for bending moment, kita tengok the diagram itself, 15 is the highest value. So, we put that is the maximum bending moment. So, ini semua you kena tulis so that you will get marks. Kalau you tak tulis, you won't get marks for this because the question specifically asks for the value for maximum shear force and maximum bending moment. Then, with the example 1.